All right, today we're cracking open the strategic playbook for one of the most critical pieces of the whole energy transition, clean hydrogen. We're going to break down the puzzle of how we get this powerful clean molecule from where it's made to where it's actually needed, focusing on the huge opportunities in that transportation value chain. Okay, let's just dive right in. We all know we need to decarbonize, right? And usually our minds jump straight to things like wind, solar, and batteries. But that's really only part of the picture. What happens when you need to power a massive container ship crossing the Pacific, or a steel mill forging girders, or, a whole fleet of long-haul trucks? This is where direct electrification just kind of hits a wall, and that's exactly the gap that clean hydrogen is perfectly positioned to fill.
So here's our game plan for today. First, we'll cover why we even need hydrogen. That's the hydrogen imperative. Then we'll get into the nitty-gritty of how it's produced and stored. After that, we tackle the core of our playbook, the transportation puzzle. We'll follow that with a hard look at the numbers in the business case. And finally, we'll map out the path to deployment. Sound good? Let's get to it.
First up, the hydrogen imperative. Before we can even start talking about moving hydrogen around, we've got to be crystal clear on why it's so vital in the first place. This isn't just, another green option on the menu. For huge parts of our global economy, it's becoming the absolute cornerstone for a truly carbon-free future. I mean, think about it. You can't just run a giant extension cord to a cargo ship in the middle of the ocean. These sectors need massive amounts of concentrated energy. But more than that, they need an actual physical thing, a fuel, a feedstock, that you can stockpile and move around the globe. Electricity is amazing, but it's an instantaneous flow. Hydrogen lets us essentially bottle sunshine and wind, and then use it whenever and wherever we need to. Now this chart, this is what really puts things into perspective. We hear a lot of good news about renewables making up a bigger and bigger slice of our electricity grid, and that's fantastic. But look at this. Electricity itself is just one piece of the total energy pie. That huge 81% over there, that's everything else. That's industrial heat, aviation fuel, chemical production. That is the massive territory where clean hydrogen is set to be a total game changer. So, here's the bottom line. Clean hydrogen is the ultimate partner for renewables. It takes that energy that's only available when the wind is blowing or the sun is shining, and it turns it into a stable, reliable, and transportable form. It's the key that unlocks the door for green power to reach every single corner of our economy, from a fuel cell bus in your city to a plant making carbon-free fertilizer halfway around the world. Okay, let's move on. We've established the why, so now let's dig into the how. We're talking about the fundamental mechanics of this whole clean hydrogen ecosystem, and it all starts with how you make the stuff. At the heart of this entire playbook is green hydrogen. And honestly, the concept is beautifully simple. You take renewable electricity, let's say from a giant solar farm in the desert. You run it through a machine called an electrolyzer. That machine basically just zaps water, H2O, and splits it into its basic building blocks, pure hydrogen and pure oxygen. That's it. No carbon emissions, just a clean, powerful energy carrier. Now, this diagram might look a little complicated at first, but it really illustrates one simple, powerful idea: flexibility. Look over on the left. You've got your renewable energy sources powering the electrolyzer to create hydrogen. The really important part is what happens next. That hydrogen can be stored, as you see there in the mill, and then it can flow out into all these different markets. It can go to industry, it can be used to balance the power grid, or it can go into fuel cell electric vehicles. It creates this complete, interconnected energy web. And one of hydrogen's real superpowers is its ability to be stored at a mind-boggling scale. We're not talking about batteries that can store energy for a few hours. We're talking about storing terawatt-hours of energy for months at a time. By pumping hydrogen into these massive, naturally occurring salt caverns deep underground, we can literally store enough renewable energy made in the summer to power our cities all the way through the winter. This is an absolute game changer for energy security and grid stability. Okay, this brings us to the main event, the transportation puzzle. This is the central challenge we really have to wrap our heads around and solve. We're getting great at producing enormous amounts of green hydrogen, and we know there's huge demand for it. But how do we physically connect those 2 points, especially when they might be thousands of miles apart? Here's the core issue in a nutshell. The sunniest deserts, the windiest coastlines, these places are rarely right next door to our big industrial hubs or our major cities. So the challenge is fundamentally a logistical one. We have to build the energy superhighways of the future to move these clean molecules across continents and across oceans, and we have to do it efficiently and affordably. So our first option is the one that's probably most familiar, pipelines. For moving huge, continuous volumes of hydrogen over land, this is an incredibly efficient, proven technology. We can build brand new, dedicated pipelines, or, and this is a really crucial point, in many cases we can actually repurpose existing natural gas pipelines. That could seriously speed things up and slash the costs of deployment. Option 2 is how we cross the oceans. If you cool hydrogen gas down to a frigid minus 253 degrees Celsius, it actually turns into a liquid, which makes it way denser. This lets us load it onto these highly specialized cryogenic tanker ships and move it around the world, pretty much like how we already ship liquefied natural gas, or LNG, today. Now, here's a clever chemistry trick. We can take our green hydrogen and combine it with nitrogen pulled from the air to create ammonia. Why on earth would we do that? Well, because ammonia is just far easier to handle and transport than pure hydrogen. You can liquefy it at a much more manageable temperature, and there's already a huge global infrastructure for shipping it. Then, at its destination, you basically just crack the ammonia to release the pure hydrogen again. Our fourth option is another piece of brilliant chemistry: liquid organic hydrogen carriers, or LOHCs. The best way to think of these is like a rechargeable battery for hydrogen. You chemically bind the hydrogen to this oily liquid, and what you get is a safe, stable, non-flammable liquid that you can transport in a regular old tanker truck or ship. At the destination, you gently heat it up to release the pure hydrogen, and the carrier liquid can be sent back to get another refill. It's a completely circular and incredibly safe system.
So let's put them all on the table and compare. As you can probably guess, there's no single perfect solution for every situation. Pipelines are mature technology, but they're not exactly flexible for overseas routes. Liquefied hydrogen is technically very demanding. Ammonia has that big advantage of using existing infrastructure. And LOHC offers amazing safety and handling, but because it's a newer technology, it's not as scaled up yet, which presents both a risk and a huge opportunity. The right choice really depends on the specific job.
And that brings us to the money. This is where we analyze the business case. For any investors, for any policymakers watching, this is where the rubber really meets the road. Which of these transportation pathways makes the most economic sense, both right now and looking out into the future? Okay, let's look at the numbers for a big international shipping project in 2025. This chart shows the total cost of ownership. So that's everything from making the hydrogen to shipping it to converting it back at the end. As you can see right now, ammonia and LOHC are pretty much neck and neck as the most cost-effective choices. Liquefied hydrogen, on the other hand, is the most expensive, and that's mainly because of the huge amount of energy it takes to get it that cold, and the challenge of it, well, boiling off during the trip. Now watch what happens when we fast forward just a decade to 2035. This is incredible. This is the power of technology getting better and operations getting bigger. We see major cost reductions across the board. Because LOHC is the newest tech on the block, it actually shows the most dramatic room for improvement as it scales up. But the costs for liquefaction and ammonia cracking also come way down. The message for investors here is crystal clear. All these costs are heading in one direction, and that's down. This quote from Roland Berger highlights a really smart, strategic point about ammonia. For some industries, you don't even need to do that final, expensive step of cracking it back into hydrogen. Think about the global fertilizer industry. They already use massive amounts of ammonia. So by just switching from their current supply to green ammonia, they can decarbonize their operations directly. This creates a huge ready-made market that could help get the entire clean ammonia supply chain up and running much faster. So, we have the technology. We have an increasingly strong business case. Our final chapter here is about how we make this all happen. This is the path to deployment. What do we actually need to do, starting now, to build these global hydrogen highways? You know, it really boils down to a partnership. Governments have to step up. They need to fund the critical R&D to help drive down costs even faster. And, just as important, they need to create clear, stable market rules and incentives so that private companies feel confident investing for the long term. Industry's role, then, is to take those signals and build, to finance the big projects, scale up the manufacturing, and just relentlessly innovate to squeeze out every bit of inefficiency along the value chain. And that's where we'll leave it today. The science is sound, the engineering is well underway, and the economics are rapidly falling into place. We have the playbook. All the pieces are on the board to create a truly global clean energy trade. The question really isn't if this is going to happen anymore. The only remaining question is who will be the ones to lead,
who will invest, and who will build the bridges that will power the next generation of clean industry and transportation.